Help me information, more than that I cannot add. Only that I miss her and all the fun we had. But we were pulled apart because her mom did not agree, and tore apart our happy home in Memphis, Tennessee. Last time I saw Marie, she's waving me goodbye, with hurry home drops on her cheek that trickle from her eye. Marie is only 6 years old. Information, please. Try to put me through to her in Memphis, Tennessee.
Hello everyone and welcome to today's UK Azure user group session. Today's talk will be all about IoT. But what is IoT? IoT is all about how we take everyday objects and apply things such as sensors in order to obtain digital information, which will allow us to produce analytics and gain insights. These insights will then allow us to actually be more responsive to changes. Businesses across the country are increasing their uptake in IoT, simply because of the fact that they gain critical business insights. For those interested in actually applying IoT in your businesses, Tomasz will go on to speak about how he used Azure IoT Hub. His talk will be all about how OVO Energy actually used Azure IoT Hub to implement an energy management system. So without further ado, I'd like to introduce Tomasz to the stage.
Can you hear me? Yes? Cool. So my name is Tomasz. I work for the OVO Energy, which is an electricity and gas provider. If you are not happy with your gas and electricity providers, check out OVO. I highly recommend it. Not only because I work for them, but I'm from the department which is called Kaluza, and we work on the IoT system. Oh, that's unlucky. Okay, I'll try with the other one. Just try the presentation again. Okay, hopefully it all works now. Yes. So the plan for the presentation today is the IoT only for seed developers? Then I will show you what's wrong with the world at the moment and how electricity and especially the renewable energy can solve these problems and how we use IoT to actually help with this. Then I will go through Azure IoT, what it has to offer to you. And after that, we'll move to demos and hopefully the Raspberry Pis will work as well. And there will be some time for questions. Okay, so I like to look at the charts representing which languages are more popular over time. And as you can see, quite recently, there is a spike in C. I believe part of it is because now we have a lot of more IoT devices and people write C code for them. But is IoT only for C developers? For a very, very long time, I thought that's the case. But actually, anyone can work with IoT. It's not just the devices that we have to create. We need the platforms which will control them. We need the applications for users so they can actually change some settings for their devices. And as well, if you just want to build something at home, then you can get a Raspberry Pi because you don't mind the cost as much as you would care about if you build a platform on a big scale. So nothing stops you to actually deploy the code in a language you like on a Raspberry Pi and just run it. So if you remember just one thing from my presentation, I want it to be this, that it's very easy to get started, and you don't even need devices to do it. But to encourage you a little more to work with IoT, that's the prediction for a number of devices over the next 6 years. Currently, we are on 8 billion IoT devices and 11 billion non-IoT. By non-IoT, I mean mobile phones, laptops, tablets. But as you could imagine, the number of those devices will not increase as much over the next 6 years, while for IoT, the prediction is that we'll get a lot more of them. And as well, there will be a lot of money involved in this sector. So even if you don't work currently with IoT, maybe after a few years, you will have the opportunity to work on a project. So why not just try now and be prepared? But let's have a look for a use case. Has anyone seen this picture before? No? So that's the average world temperature over the last 150 years. As you could imagine, the blue means it's colder, the red means it's warmer. The difference is not huge. It's just 1.35 degrees Celsius. Is that a lot? Well, if my body temperature rises by 1.35, I'm sick and I stay in bed. And as well for our planet, it's not very, very good. But there was a research, what will happen if it carries on like that? So if we increase the temperature by another 1.5 degrees Celsius, then more than 271 million people will be exposed to water scarcity. But you know what? We are so far north, we don't really care about it. It's not our problem. How about flooding? If it carries on like that, even more ice will melt and the sea level will rise by 40 centimeters. That will cause flooding. And if you work in London, that's a city which will be very much exposed to it. And the cost for UK will be 12 times as much as it is now. So no, I don't really think that it's fine. The other issue, the wildfires. When I hear about wildfires, I usually think about North America. They have massive problems over there with them. But even for Mediterranean, it will increase by 41%. Just last year, there was this massive fire in Greece and 100 people died. So if it carries on and even gets bigger, that's a huge problem. What we connect to increase in temperatures is how much CO2 we release. And over the last 150 years, you can see how it was growing. And the prediction is that it will carry on like that. So who is contributing the most to this? If you look at this chart, you can see that energy is the bigger contributor. And inside the energy, the electricity and heat contributes to 31%. So if we could just solve this one problem, it will make a massive impact. But as humans, we are very, very good at learning from the past. We take the ideas which we know about, and now we apply them for new use cases. So for example, the windmills were built in the year 600. The water mills are more than 2,000 years old, and now we actually use them in generating electricity. But it's not only that. So if electric vehicles, you all know about Tesla. It's this modern invention, electric vehicles. This is awesome. So this guy in the middle is Thomas Parker. He worked on electrifying London Underground, and as well he built an electric vehicle in year 1884. He wasn't even the first one to build an electric vehicle. On the other picture, you can see, you can see Thomas Edison standing to something which looks a lot more like a modern car. I believe it's a Detroit Electric. That was one of the most successful electric car manufacturers back then. And I found some interesting statistics about electric vehicles in year 1900 in US. 40% of them were powered by steam, but 38% were powered by electricity. If we had now on our streets 38% of cars which were electric, we'll all celebrate this great achievement. But 100 years ago, that was just a norm. And 22% were powered by gasoline. So I mentioned the renewable energy and how we can generate it. Is that what we do? Well, unfortunately not. Most of the electricity come from coal and gas, so we just burn stuff to generate it. It's not really good for the environment. There is a website called GridWatch, and what it allows you to do, you can have a look how much power is generated from different sources. So for example, it's very nice that from coal we don't generate anything for quite a while now, but still from gas, 41% of electricity is generated. But there is as well some good news. So I found that one a while ago. In February, there was a record for how much electricity we got from wind. It was 36%, and it was 15.3 gigawatts in total. The other interesting information, Denmark is able to generate 140% of electricity just from wind farms. And it's not only that. Wind is not the only source. Only 2 minutes of sun gives us enough energy for a year for entire humanity. If you just power 0.3% of Sahara Desert with solar panels, that would generate enough electricity for entire Europe. And we don't use Sahara Desert for anything else. It's just sand over there. Nobody would care if we build those solar panels. But it's not as easy. We can't just change the weather. We can't make the sky blue when we need a lot of sun. We can't force the rain to fall, and we can't force the wind. So what we want to do is to store the electricity when we actually generate a bit more. What happens at the moment? You can't easily turn off power generators overnight, so we have to somehow use this electricity. There is this idea of pump storage plants. They are one of the most popular ways of storing electricity. Overnight, when we have a lot more, we will then pump the water up, and then during the day when we need this electricity, the gravity will move the water down, the turbine will generate power, and we will send it back to the grid. The efficiency of that one is between 70 and 80%, and that's one of the best ways of storing energy. If you are interested, that's the biggest one in the UK. It's in Wales. You probably can go there and have a look. But let me show you what I'm working on. Have you heard about storage heaters? Maybe you heard. They look like that inside. They just have bricks. So how they work, overnight when the electricity is cheaper, they will heat inside, and then during the day, the bricks will keep the heat, and they will release it. But there are a couple problems. So for example, during the morning, it will be very, very warm, while during evening, it will be quite cold. And as well, they don't have any idea what will be the weather next day, so you just have to charge always by the same amount, which is not very good for customers. So we built devices, and at the beginning, we just used light bulbs to check if they work. Because if you think about it, it's pretty much just turning something on and off. That's all we do. It's very simple. So if we use light bulbs or if we use normal storage heaters, it doesn't matter. And later we got something more professional. And what I enjoy the most about this work is in the past I would work on some desktop applications or websites, and it was only on my screen. But actually with all of this, I can touch what I'm building. And it's always funny when you hear all the light bulbs turning on because there is an off-peak time and the electricity is cheaper. But retrofitting devices is not a good idea. If somebody wants to change their heating in the flat, they will use something else, something modern. So they will not go for those old devices. So recently we started a partnership with Dimplex. They're one of the most successful storage heater companies. It's a lot more efficient, and they already have an option to communicate with them from the cloud. So we just have to integrate with their system, and then they will send all the commands to the devices. I mentioned electric vehicles, and we built the smart chargers as well. So now if you buy an electric car, you just get a cable. You plug it in when you arrive at home and just leave it there. Of course, the electricity is the cheapest around 2 a.m. Nobody will set an alarm to just quickly run to a car, plug it in, because now it's cheaper. With a smart charger, we can actually decide what's the best time to start charging the car, so then you have lower electricity bills. But there is something even better. So I mentioned storing electricity, and that's the vehicle-to-grid charger. As you can see on this picture, that one is a lot bigger than the smart charger. The reason for that is it has an inverter built inside. So we take the electricity from a car battery, which is a direct current, and we convert it into the alternating current, which is on a grid. So actually, you can plug in your car and use it as a normal battery, which will power your devices at home. But I talked about helping the environment, so how this all connects together. If you wanted to deploy all those devices next to London, nobody would allow you to just turn them on and off when you want. That could cause a blackout, and many people would be affected. But what you can do, you can just deploy it on an island, because less people would be affected. They often have their own generators. So for example, we had a project on Mal when they have the community hydro plant, and they would like to build another one, but because of the constraints, they are not allowed to do it. So in fact, this electricity which could be generated is not happening. They just have one of them. And what we did, we connected to it and then turned on our devices when there was more electricity. So you can see over here, there is the rain rate. And with rain, the water level is increasing, which you can see here. That correlates to electricity we are able to generate, which is this yellow line over here. And then what happens, we have this chart with how much power we are exporting to the mainland. And at some point, we get the signal that we are not allowed to export anymore, and we have to consume this electricity, so it's not wasted. So we turned on our devices, and you can see it here. There are two lines. One is how much we predicted that we'll be able to turn on. The other one is how much actually we're working at this point. There is always a problem with IoT. If you lose the connection and you send a signal you want to do something, they may not respond. So that's why you often see the difference when you run it. But then you can see we actually exported a lot less electricity. The other project, which was very similar, was on Orkney, and this time we integrated with the wind turbine. So if you think about wind turbines, they can be either on or off. There is not an option to generate less electricity from it. I mean, there are some, but then it's a lot more complex because they need different gears inside. So what people do, they usually build the cheapest option, which is just either it generates electricity or not. So that's why often you can see a wind farm where a couple of them are running and the rest is just standing still. So in this case, we just had the wind power displayed here, and then that's the electricity we're generating, and our device is just turning on during the day. So how it fits with the Azure IoT. So Azure provides a lot of different services. And for example, you can display your devices on a map. You can do some analytics on the messages which arrive from the devices. What is really cool is the IoT Edge. You may have heard about the idea, instead of running something on a server, you could just push it to a client. So when somebody runs some JavaScript in a browser, it will do a lot of calculations on the client side, so you actually save the resources on your servers. It's exactly the same idea, but in this case, you can deploy something to a device, so it will make a decision on its own without even communicating with your platform. It's kind of deploying the Azure function to the device. But what I want to talk about is the service which you need if you want to talk to the devices. That's the minimum, and you can just do something just with the IoT Hub. So what is IoT Hub? IoT Hub is built on the Event Hub, so you get some features from it. For example, the devices can send messages to your platform and you can consume them. There are different protocols which are supported, such as AMQP and HTTPS. And at the beginning, people were just using Event Hub because it was cheaper than IoT Hub. So what Microsoft did, they lowered the price of IoT Hub to match the Event Hub, so then people would actually use the service which was built in mind for the IoT devices. But as well, it provides you with a lot more options. So for example, the other protocol which is supported is MQTT. If you just communicate from the cloud directly to your device, that's the one which is recommended. With AMQP, you should use it when you have a gateway. So for example, you have a couple of devices in a flat, and then you want them to communicate with the cloud, but you don't want to build them with the Wi-Fi built inside because that's additional cost. What you can do, you can have this one device which is a gateway. It will communicate with the cloud, but then it will distribute messages to those different devices in your flat. The other thing which is quite important is this per device identity. So you know exactly which device is sending those messages, and as well, they authenticate as a single device. So with the Event Hub, it would be often the case that they would all have the same connection string to send messages, which is obviously not good if you build it this way. But with IoT Hub, it's built in place already that they all have their own unique identification. And there is an option to communicate the other way. So we can actually send some commands to those devices. The other useful concept is the device twin. The device twin, if I try to compare it to something you may know, it's like the LinkedIn profile. The LinkedIn profile is not you, it's your virtual representation. And that's the same with the device twin. It's just the virtual representation of the specific device. So for example, if the device is offline for a while and you would like to tell it, when you come back online, change your firmware to this specific version, if you change the property on the device twin, at some point when the device connects to the IoT Hub, it will get this information and then it will know, oh, I should update my firmware because there is something newer available. And the IoT Edge, which I mentioned already, and a couple more things. So let's go to the demo. The first thing which I want to do is to create an IoT Hub. So if I just go to the browser, okay. So to create an IoT Hub, it's very simple. You create it as like any other service on Azure. I will deploy it somewhere close to here. Cool. The other thing is the size and scale. So by default, it's the standard tier, and it costs you £18 a month, and the limits are 400,000 messages per day. But if you just want to play with it, there is an option to create a free tier, so you don't have to pay for it anything. Obviously, the limits are more strict. It's just 8,000 messages per day. But if you are just building something for you to play with, that's good enough. The other thing which I want to mention is the advanced settings. So that's the device-to-cloud partitions. For the free tier, you only have an option to have 2. I will come back to it later when I show you some code. So now I will create that one. While it's doing this thing, I will go to VS Code, and there is an extension which is called the Azure IoT Hub Toolkit, and it allows you to explore your Azure IoT systems and as well display all the devices, communicate with them. So it's very simple. You don't even have to build anything. You don't have to write any code to actually communicate with those devices. So if I now connect to one IoT Hub, which I had prepared already, you pick your subscription. Actually, maybe the first try is already created. Let's have a look. No, it's still deploying. Maybe it just remembers the previous demo I did. So if I go and I pick backup, so that one should have a device already. Yes, we have kitchen. So what we can do, we can start monitoring messages which we get from the cloud to this device. So we'll pretend that we are this device. So it starts monitoring for this specific device. What we can do, just from this plugin, we can send a message. So it's cloud to device. If we send that one, you can see here we received this message for this device. But as well, we can do it from the portal. So if I go back to the Azure IoT Hub, okay, the other one got deployed, that's cool. So if I have a look, there is a list of all the devices. So I should see exactly the same thing which I saw in the extension. And now we can send a direct message. So if we send that one, hopefully we'll see it in the extension as well. So that message was sent, and if I have a look here, you can see it all worked. So that's cool. But of course, we would like to run some code. I will now stop listening to all of that, and let's go to the IoT Hub I just created, which was this first try. So what we can do, if we go to the list of the devices, we can manually create a new device. There are different options. So for this demo, I will just use connection strings. But if you build something on production, I would highly recommend to use certificates. The other service which we use is the device provisioning service. So it helps you to deal with all this setup. because Microsoft realized at some point that's quite a common scenario that people want to use certificates on the devices and be more secure. So then that's the other service which I would recommend to have a look at. For now, because it's just a demo, I will show you. Cool, so we have a bedroom now, that's all good. Okay, we have the keys here, so I can have a look. That's the key for this specific device. If I go back to VS Code and I connect now to the other IoT hub, so that's the first try, you can see the device is refreshed, so we have now bedroom. What I can do, I can actually generate code from here. There are different languages which it supports. I will pick C#. And now if I just go, I'll create a new folder for it. So if I select this folder, it will create all the code for me. If I just have a look at this file, we have the connection string. Okay, I'll run the restore for that one. So we get all the libraries which we need. But if you have a look on the connection string, we have the information, that's the bedroom, which is our device, and now this shared access key is the key for this specific device. So if I go back to the portal, that's exactly this key. So without doing anything, this extension knows which device you picked, and it will populate your code template. Now what happens in this code, if I go to the main method, we create our device client for which we use the connection string, and as well by default it picks the MQTT because we just communicate with this specific device. And then we run a method which will send some messages to the cloud. So if we have a look at this method, it just has some temperature and humidity, and then we will add some random values to it. So in a loop, we generate a new temperature, which to get different values every time we send a message. We have humidity, which again will be generated. And then in this case, we use anonymous object in C#, but you could define your own class. Obviously, when you build something on production, you probably want to be more constrained. And as well, I would recommend to use something like the protobuf when you communicate with the device. It makes it a lot easier. But just for a demo, what we'll do, we'll get this object, we'll serialize it to JSON, and then we will get bytes because that's what's expected inside the message. As well, you are able to add some properties to your devices. So for example, I will add the temperature alert, and then if the temperature is above 30, we'll just send true, otherwise it will be false. And the main part of it is just to send this message to IoT Hub. So now if I go in the terminal, I will run this code. And if I go to the other VS Code, which I had open here, I will start listening to actually messages which arrive from the device. So you can see we are receiving something with this alert as well set up for this specific device. So we got something working, communicating with the cloud. We are able to see those messages without writing a single line of code. So if you just have a bit of time tonight, just try and play with it. It's all free, and it's all easy to set up. So I will stop that one now. Cool. I don't need this one anymore. Now, if I go back quickly to the presentation. So we just got the IoT Hub deployed, and we are able to communicate with it. But I would like to show you something which is more related to what we are building at work. So if I go to the next slide, the first part would be to slightly change this code and now just send the room temperature, because we deal with heating, so that's what we need. If I now go here, I have different examples, and as well, I will need the configuration to be correct. So I have a script. Actually, if we go here. So I will run the script. While it's doing its thing, I will show you what I have there. So it simply just uses commands to get the information, for example, the specific device connection string, and as well all the Event Hub endpoints, and as well the IoT Hub connection string. So it will get all those values for me, and in a second, when it generates all those files, I will show you, I think it's done this thing already. So that one should be exactly the same like we had in the other code, because it's exactly the same device. So we have here this specific key for it. If we look at the service, then we will have a couple more properties. I'm using the IoT Hub owner. Don't use it on production. It's just for a demo. But if we have a look actually on the Event Hub side, if I look at the portal, so for that one, we have the built-in endpoints. And for example, you can see this endpoint value, that's what was populated in the configuration here. And as well, then we have the key name and a key that we can find if we look at these policies. So we have the IoT Hub owner, and that's the key which we use for it. So that's the settings which we need. If I go now to the code, let's have a look at the device. So it's exactly the same what happened previously, but this time I'm just using the date value from the configuration. And then we create now our client from this config, again with MQTT. And then we run our method, which this time it will only send the temperature. So it's very similar code. The only difference is it will have the temperature as an object which we send to IoT Hub. So if I go now here and I run this code, hopefully we'll see that it's sending something. So yeah, we are sending those temperatures now to the IoT Hub from this code, which is cool. If I look at the slides, so the next step, we would actually like to process those messages on the other side. We want to build a service which will deal with it. So that's the next step. We'll get those messages from the IoT Hub and start processing in our application. So if I go here and in the service code, I can close that one now. So what happens here? We have to read from Event Hub. So we create the Event Hub client based on the Event Hub connection string builder. So we get all the endpoints and all the additional information which we need. Then what happens, hopefully you remember when I mentioned those two partitions when we created the IoT Hub. That's when it comes in place. So we get the partition IDs, and then for every partition, we have to start consuming messages. So if I look at this code now, we start a receiver on this consumer group. If I look at the portal, and we have the built endpoints, that's the consumer group. So that one is built in. You can add your own as well if you want. And now what happens? We just run the receive method to get our events from IoT Hub. Because it can be a list, sometimes it can be empty as well. We just want to go with the for each through it. So what happens, we get our body, we convert a string, and then we will display this value in a terminal. As well, I mentioned before the properties which you can set when you send the message. So that's the properties on this specific event. But there is the other thing, which is the system properties. This thing is what IoT Hub will set on this message for this specific device. So if I go back to my code, and I will run the device again, because we want something sending messages. And now, if I go to a service and run it as well, hopefully we will see that what the device is sending, we should start seeing when it starts the receiver. So we have 22, 25, 25 again, 30, 31, 21. I will stop the device now. So what you can see, we no longer have any properties because I didn't have anything in code which would set those properties. But what we can see is, for example, the device ID. It's bedroom. So that could be quite useful when you actually want to send then a command to this specific device. And as well, you get like the sequence number for the messages you received. And that's the message source is the telemetry, which is the messages we receive from this specific device. And as well, what you can do if you don't care about most of those fields, you can just say, oh, from the system properties, I want to get my device ID. And then you can use this device ID to do some extra processing. But that was one part. What we want to do next is to actually act on those messages. So our service will have to send something to the IoT Hub so it can provide the data then to our devices. So if I show you the other example, we want to send commands. So in that one, it's very, very similar to the previous example. So again, we want to build our Event Hub client, but as well what happens now, we have the IoT Hub connection string. So we will create a client for the IoT Hub to actually send messages the other way. And again, what happens, we have those partitions, and then we receive some messages on it. So that's the same code. We read on default. We get our events from IoT Hub. Then we convert it to get the data. And what happens now, I'm parsing the data to have a temperature. And as well, I get the device ID. And here I have the code which checks if it is above 23 degrees, then I want to turn off my device. If it's below 19, I want to turn it on. And in this case, I simply send a string. But again, if you want to communicate with the device, it would be recommended to use something with some defined formats, such as protobuf. So we generate bytes for this specific message, and then we send this message to IoT Hub. So if I go back here, and we start our device again, so we receive the telemetry from it. And now I will start my service. So I started the service. It should receive now the temperatures. So if you look, oh yes, we received 20. Oh, 24 was too much, so we want to turn it off. And then it carries on like that. Because the values which we generate are quite high, it usually just says, oh, turn it off, turn it off, turn it off. The temperature is too high. So if I stop it now, of course, nothing happened on the device. The reason for that is we didn't implement yet this part, which will read from here and do something on our device. So if I go to the next part, that's what we want to do. That's the part of code which we want to implement now. So if I go to VS Code, I have an example where what happens now. So again, we simulate our heater. And this time, I will simulate it slightly differently. So I want to pretend that's the real device, and the flat will heat over time when it's on. And as well, it may be cold outside, so the temperature will go down if the device is not on. So that's what happens here. I just check the flag, and if temperature is below, then we'll keep adding the value. And then if it's off, we'll keep going down and do minus 0.5. So we can quickly just simulate the temperature difference and hopefully see that our service will act based on those temperatures and schedule correct commands for our devices. And then again, we just want to send this temperature to IoT Hub, and that's the same code which was previously. But in this case, the difference is we as well run this method, which is the receive command async. So we are looking for some commands for this specific device, and then we'll get bytes from the message, which will be our command. And then I just convert it to a string, and then we check if it's turned on, I'm setting a flag to true. If it's turned off, I'm setting it to false. And then we'll just say, yeah, the message was completed, I'm all good. So if we run now, that's a different device. And we run different service. And as well, what you can see, we received quite a lot of turn off commands. The reason for that is when you send messages to your devices and it's offline, you still want it to process them when it comes back online. Obviously, not all of them. So the limit is 50 messages. So then what happens, the device will receive those messages and will process them when it's online. But as well, we don't care about some old messages. So yeah, what happens, we receive the turn off at this point because it was above 23 and the temperatures are going down. And then hopefully when we go quite low, we get, oh, turn on, and it will keep going up. So that's this part of the demo. And of course, everything what I just ran was on my device. So you don't even have to run any Raspberry Pi or anything like that. You can just play with IoT Hub on your own, build a couple console applications, run them, and just see how they all work together. But I would really like to show you how it works on devices, if it works. So I want to simulate kind of the grid. So what happens when we have like the wind turbine, they provide the data on the Modbus protocol. So that's quite common use case. And then we have our device, which is listening on Modbus, and then it will send the information to IoT Hub. when we receive it on the IoT Hub, on the service side, we want to let our devices know that they should probably turn on because we have an extra electricity. So that's something I will try to run on Raspberry Pis, but that relies on Wi-Fi, and those things usually don't work. So I will start the demo. Okay, that's good. If we just go portal, I refresh this page. Hopefully we'll receive some. Okay, so we received just the telemetry for those two LEDs. And now if I open it this way, hopefully you can see. So we have two LEDs here, and as well I have the Raspberry Pi with a sense hat. So I will simulate now that we get some extra electricity by turning it on. Hopefully it will display. If not, I'll just restart everything, because that's the other option to solve problems. Well, I had this problem before. So the most annoying part with working with IoT, and it's as well on production, if they lose connection, there is nothing you can do. So what we do with our real devices, they have the home alone option. So if they can't communicate with IoT Hub, they will make their own decisions, because obviously we still want to deliver heat to customers, so they shouldn't rely just based on us not being able to communicate with them. But hopefully I'll just restart a couple of times and then it will work. If not, I'll just show you a video of this. Okay, that one didn't start yet. Now it's, oh, cool. So you can see it displayed 1, which is the number we get from this device, and as well it turned on this LED. And if I add 1 extra, then you can see the second one, which is that one, is now on as well. Maybe if I move it a little bit and spread them around. So now if I go 1 down, hopefully, yeah, we got the message 1, and 1 now is off, and then we do it for the second one, yeah, the other one is off as well. So what happens, you can see as well slightly delay when I do it. So when I press a button, this device sends the message to the IoT Hub, and then I have application running on my machine, which gets this number. It displays 1, and then it assumes, oh, I should turn on one of those LEDs, and it sends the message to one of those devices. When it receives that, it will turn on LED, and then it will send the telemetry packet I'm on now. So you can see slightly delay between when we receive the number, it sends the message, and then the LED should change on a screen after it changes on the real device. Ooh, I'm glad it worked. So yeah, that's it. And that's pretty much the end of the presentation. If you would like to join us, we are obviously hiring, and I highly recommend what we are working on. I really enjoy it. So I mentioned all the happy stuff which works. Maybe I should tell you a bit about things when they go wrong, and sometimes they do. So I have 3 stories which I remember. One was 2 years ago, so it's no longer the case, it's all very stable. But 2 years ago, it was a December, and we delivered heat to our customers. And one day, we didn't receive any messages from our devices, which was very scary. Fortunately, we had this home alone option, so we knew that the device will still deliver the heat, but you really don't feel comfortable when you know your entire platform is down. So we had a look what's going on, and we contacted Microsoft support to get some information, and in a couple of hours, they fixed the problem. So what happened? Somebody else was running their own IoT Hub, and they got a lot of messages, and they DDoSed our IoT Hub. So it was the first case for me when actually some completely different application, not related to our company at all, killed our system. It was an exciting time. It never happened again since, so that was all good. The other 2 things are more related to kind of a human error. So I mentioned the number of partitions. You set the number of partitions when you create your IoT Hub, and we set it to 4 when we did that. And quite recently, we started having problems that we are consuming from the Event Hub from different applications, and the performance was not that good. So one of my colleagues looked at how we could increase the number of partitions, and you can't. You just can't change it. So what we had to do, we had to deploy an Event Hub as an extra application, then just send all those messages from the Event Hub inside IoT Hub on those 4 partitions to an Event Hub with more partitions, so we could actually consume them all and be quite performant. And the last bit, which was actually my error, so I mentioned the limits on IoT Hub, and they are per day. So I worked more on the data science part recently, which is making all the decisions, how we want to control it. And that's obviously the slowest part because we do a lot of calculations. So recently somebody looked, oh, we don't send enough commands. Could you just change something? So I thought, oh, I will just scale our system so we can actually process a lot more. So that happened on Wednesday afternoon, something around 2 p.m. I scaled it all. I told the other team, oh, you may experience some problems because you will now receive a lot more commands. But it looked all stable. I went home. I came back on Thursday. Everything was fine. Everything was perfect. Then I went home at the end of Thursday. I came on Friday, and my colleague came to me and said, oh, you know this change you did? Last night, the IoT Hub stopped processing our messages. And it was around 11 p.m. So what happened? You have a limit per day. When I deployed in the afternoon, most of the day we still were sending the number of messages we used to. And then for the rest of the day, which was about 10 hours, we sent a bit more, but it was still inside our limits. But on Thursday, from the beginning of the day, it was sending a lot of messages. So actually at the end of the day, we hit the limit and it just cut it out. So my colleague had to increase the size of the IoT Hub and how much we can process. So it's something you have to be careful because it's per day, and obviously if it happens, it's usually at the end of the day. But yeah, other than that, I had very good experience with IoT Hub. If you would like to play at home, I wrote a tutorial which is pretty much a description of all the steps I did with like creating IoT Hub and communicate with it from the VS Code. All the code is on GitHub as well. I will share it later on the Meetup page, so you can go and play with it, which I highly recommend. As you saw, it's nice and quick and easy. So yeah, if you have any questions, feel free. Yes? Maybe with the microphone.
Hello everyone, my name is Arun. You spoke about that you were running short of the message capacity and your friend had to manually increase it. I mean, can't you auto scale those things? I mean, I'm sure there would be some facility for that.
So currently we mostly rely on the monitoring, so we know how many messages we sent already. We haven't looked on the auto scaling. We still want to have this kind of manual control about how many resources we are using and why we have a lot more messages. Because you could have a scenario when somebody breaks into your device and then this device will send a lot of messages, and that would actually increase the load on your platform. You still want to identify those anomalies. But I'm sure you could do something about the auto scaling. I just haven't played with it in this way.
Okay, thank you.
Yeah, any other questions? Yes, we have one person.
What's your testing strategy? Are the IoT hubs testable?
So in terms of testing strategy, as you saw on a picture, we had our devices in the office. So that's how we, for example, if we have the new firmware version, we'll deploy this new firmware and we'll check if they still perform correctly. We are as well quite lucky that with the smart chargers and the vehicle-to-grid chargers, they are built by the internal company, so we work very closely with them. And usually we just have the test. It's kind of manual testing. When they plug in the device, they check if it's working correctly. We then monitor if we are sending all those all those commands. And in my experience, mostly problems which happen are actually on the firmware side and on the device itself.
Do you have a separate environment in which case you
Yes. So we have 3 different environments. One is like dev, which is pretty much when we do development and just want to play with it and it can break anytime. Then we have staging, which is more like the environment very close to production. And then if they want to test something with the real device, they would connect to staging. And then that's where we will test it. And then sometimes they plug into prod as well, because I mean, it's not a problem if they just build the new device, they just want to plug it in, plug it to a car, have a look if it works, then of course it's fine as well. Any other questions?
That's a lot of technologies on the last slide.
Oh, sorry.
Can you, no, please show it. Can you give us an idea of how you're using them all, how they all fit together?
Okay, so how they all fit together, I would say one of the most important is Kafka. So what happens, we use the IoT Hub to communicate with our devices, and depends like what you build. If you build a website, you may consider an event-driven system. When you work with IoT, you pretty much don't have a choice. You get events. The messages will arrive like anytime, and then you have to act on them. So what happens with the IoT Hub, because it's built on top of Event Hub, Microsoft enable as well reading from Event Hub like from Kafka, and Confluent has an application called Mirror Maker, which allow you to copy the messages from one topic to the other. So we just had to deploy the Mirror Maker, and that would push all the messages to Kafka. And then in terms of the rest of processing, so we run our services in Kubernetes, and that's just to allow easy scaling. So for example, the use case which I mentioned that something went wrong when I actually scaled, that was I increased the number of partitions on Kafka so we could have multiple deployment, like the same application as multiple instances processing those messages separately, because very much what happens is independent decisions. So when you plug in the car to a charger, you are individual customer, and we just have to make the best decision for you. We don't care about all the other customers, at least at the moment. If we had more integrations with renewable energy, then of course we would care a lot more about the entire fleet and make a decision, oh, maybe we should turn on 100 devices here and 200 somewhere else, and then later switch those devices and turn them off and turn on something else. But yeah, with like the Kubernetes, it was very easy to just scale horizontally, and then they would start consuming from different partitions in Kafka. In terms of languages, so we use Python for the data science. Quite obvious. I mean, at least what I heard. We use Go for the device integration side of it. So the other team actually works with the IoT Hub, and as well, when we have the extra partnership, it's quite often cloud-to-cloud integration, so we no longer have to communicate directly with the devices. So for example, with Dimplex, they already provide a platform. They have an event hub from which we consume, and as well they have the API which we just have to call with different schedules, and they will distribute those messages to their devices. So yeah, in terms of like the UI, it's the React, and they use the GraphQL as well when they have some REST services which they want to query. We use two clouds. I'm not sure if I'm allowed to mention the other one. One of them is Azure. And yes, Docker, of course, like Kubernetes, that's, I think, quite common scenario. And we use CircleCI to build our code. So yeah, that's pretty much it.
So the UI which you displayed initially when the bug was lighting up in another building?
So that was just my demo. So yeah, that I built in .NET. Yes, yes. So that was .NET. On Raspberry Pis, I'm running Python. I was playing with .NET on the Raspberry Pi, but I still find Python a lot easier to just push a script to Raspberry Pi and run it. It usually works without problems. Another question.
What do you store your data, and what platform do you use to store it? Do you use like a data lake or something like that?
So what happens, for example, with all the Kafka messages, well, I'm not sure I'm allowed, but we use the BigQuery from GCP. So we have the auto-ingestion, which was built internally at work. So what happens from every topic on Kafka, when we create a new topic, it will automatically get this data and send it to BigQuery. So then we can easily just go through the historic data. So quite often on Kafka, we would have like limits. Oh, we only want to keep this data for 3 days, and after that, it may disappear. It obviously depends how Kafka decides when it's good time to delete these messages. But when you set up 72 hours, it means we promise you 72 hours. You may have a bit more if we don't decide to clean up the old messages, but usually they will disappear. And then, of course, we want to keep this historic information, especially from the data science point of view. They want to keep this data, so when they create new model, they can actually play with the historic information and make better decisions. Otherwise, you would just have 3 days of packets, which is not enough to build something useful. And then inside different teams, there are different technologies used. So for example, with my team, when we just get the information about parameters of those different devices, we just use Postgres because we didn't have a need for anything bigger and more powerful. It's still quite an early stage for us, so we are trying to integrate with as many different type of devices as possible, and different companies which build them. So now we look as well at the batteries which you can install at home. So for example, the PowerVolt and Sonnen are two companies we now started discussions with. The other things which I could mention, I think is quite cool. So we have the chargers. If you get a charger as an over energy customer, then we will make a decision based on the price. But as well, we have the other option, which is, I think, Charge EV. They install the charger just as a charger, and people are quite often on a flat tariff, which means it doesn't matter when you charge, you still pay the same amount. But there is an API from National Grid, which you can query, and you get the information, the forecast, how much CO2 will be released when we generate electricity during different half hours. So then when we know that the price is flat, we make a decision based on the CO2 emissions. So we can actually reduce the environment impact, which I think is quite cool. And one of the most recent features was the solar matching. So you can actually decide, I want my car to be charged just from my solar panels as much as possible. Of course, if you have some settings that you want your car to be ready at 7 a.m., we would still decide, oh, we have to charge from a grid as well because you don't have enough electricity in your car. But we will still try to get as much as possible from the sun. Another question?
How do you deploy changes to the IoT device firmware itself? Do you send a message to get it to fetch?
So I mentioned the device twin. So on device twin, we would set that's the firmware which we want you to pick. And as well, we have the information where you can download the firmware. So I think it's stored somewhere in a blob, and then they can just get this latest version. Quite interesting thing as well with the devices, which I didn't know before I joined. So with the storage heaters, we have those dynamos. And if you get the new firmware, you start this new firmware, it breaks, what do you do? So what usually happens, you have two partitions on your device, and then you have on the one partition your old firmware, then you get the information, there is a new firmware available. You will get this firmware to the next partition. It will start your device using the second partition with the latest firmware, and there is some watch on your device, and it will check if the device is not starting correctly, something went wrong, the firmware is not working, I have to go back to the previous partition. So that's actually quite nice rollback strategy, and yeah, we had the scenarios with actually device, the firmware was broken and it had to go back to the previous one, and then we were able to fix the firmware, push it again, and then it would apply correctly. So that was very, very useful, especially with IoT. With normal website, you just deploy again to your service. That's simple. With IoT, you just have to send somebody to go and change the device, which is obviously a lot of work. Cool. Any? Yeah?
The multi-cloud strategy, is that by choice or by chance? Is it based on cost, availability?
So the cloud decision. Interesting story. So when I joined the team, I was just a C# developer, and most of the people were C#, while from the OVO Energy, it's very much Scala-based. So the Scala people mostly use AWS and now GCP as well. But we went for Azure because as a .NET developers, that's like the most obvious and common scenario. So we picked that one. But then over time, we looked at different technology, and then we started using Kafka, and as well, we started using Kubernetes quite early. And then when we looked at the availability, the GCP back then was more mature from the Kubernetes perspective than it is now. I mean, now probably the decision wouldn't be obvious. Back then it was, of course, like Kubernetes came from Google, and that was quite mature technology back then when we decided. So that's why we have GCP. And as well, the BigQuery, I don't know if on Azure there is something similar. BigQuery is very powerful, at least from my experience, and the data science people were very keen on using it. So I guess their knowledge about this technology from some previous company influenced them to be happy with GCP in the first place. So we had these two clouds. We had Azure for the entire platform, and we have the IoT Hub, for example, while we had the GCP with the BigQuery. And then when we thought about using Kubernetes, we just decided to deploy it on GCP. But again, that was, when was it? 2 years ago almost? Quite a long time ago.
The data transfer costs all
All the transfer goes through Kafka, and we use Aven, so we don't host Kafka ourselves. If you want to host Kafka on your own, it's quite a lot of work because there are plenty of settings and you can easily make a mistake. So we use Aven, which is kind of a cloud provider. They use different clouds to deploy Kafka and then maintain it. So it's a lot less work for us. We just rely on them. So we send the messages to Kafka, and then all the processing goes from there. So it's already kind of between cloud communication in the first place. Any other questions? You can always just talk in person to me once we finish, so feel free. Cool, thank you very much.